Hello and welcome to week 4. We are on our way to the finish line. Let me share some things with you for the week. Um, let's just recap. As you noticed that with week 1, we started off with the graphs and um, systems of equations. We were modeling functions in the unit 1. With the week 2, we were still dealing with more functions. We had in week 2 to deal with complex numbers, solving graph polynomial equations, find the domain in asymptotes of rational functions. So week 1, we started off with dealing with linear, more or less linear equations, which is a review of the college algebra. But if you notice in week 2, we gradually moved into the nonlinear portion, dealing with exponential equations, log equations, variation problems, rational functions, polynomial equations, which are all nonlinear equations. Okay, so that was dealing with week 2. And then in week 3, we got into the trig branch of the class. And the trig, we're dealing with triangles. So we're dealing with shapes. We're still dealing with equations or identities, trig identities. But we get into the shapes and the modeling trig functions, dealing with the right triangle in week 3. Now, and also remember that the project was broken up into parts. Part A, you had to give your title, your 2 variables, identification of your 2 variables, and your hypothesis statement, which basically gives your perception of the relationship that will happen between the 2 variables. And then in part B, you went to collect data of your 2 variables, okay? And you wanted to make sure that you were dealing with 2 quantitative data. Now, in your project, you can deal with other data, okay, which may be qualitative, okay? Because data can be both quantitative and qualitative. But for our graphing purposes and modeling purposes, we need to deal with the quantitative variables, okay, when we're modeling and graphing and collecting the data for that. So you want to make sure you're dealing with the quantitative. And so part B, most of you submitted your part B. Some of you needed more time, which is fine because part B is the meat of the project. So it's about collecting the data, okay? You need to have 10 pieces of data for both variables, okay? And that needs to be in table form. Let me go back and recall, let's see if we go back, just so you can remember what the, how it looks. Remember that you want to make sure you put your data in table format. And I don't want to, let's see, I don't want to play that. But if you go back to the week 3 video, okay, and on a sample project, it has the table in the sample project. And again, you remember how I said I wanted you to tell your story. So don't just post a small paragraph, okay, which has like what you're doing your topic on and your hypothesis statement, and then you go into your, this is my data. Talk about it. If you're dealing with the homelessness and the interest rate or whatever, why does homelessness exist? Okay, why is the interest rate fluctuating? So it has to be some type of answer or response in reference to, you know, the fluctuation in the interest rate. Why is there, you know, why do we have homeless people? I mean, do some research and see what you collect and incorporate that into your project. Okay, make it your story. All right, so that's part B. Don't forget your graph. When you collect your data and you put it in table format, okay, you should also make sure you describe, you know, how you collected your data, what's in your table, what is it saying, what's included, and then you want to make sure you have a graph, a scattered plot of your data, and not only have your graph, but explain your graph in details. Okay, how are the two variables related in your graph? Okay, as the years increase, is it what's happening to the other variable? Okay, um, that kind of thing. And so, what type of relationship? Okay, or non-linear relationship is what we're looking for. Okay, because it's easy to see a linear relationship in any of the graphs, any scattered plot. We can get a linear relationship from any of them. We want to deal with the non-linear. Okay, and from what I've seen so far, most of your relationships can be seen in exponential form. And I did post I do have a video on how to find an exponential model. Okay, and so you can look at that and see if that helps you with your particular graph or data. Okay, there is another method. Okay, if this method does not fit yours, and it's dealing with the systems of equations, and I can show that if needed. Okay, it's a little bit more intense than this basic model. Okay, but if you're able to use that one, that one's good. The other one, the way I solve it is dealing with the systems of equations, which you dealt with in the week 1, okay? Week 1 or week 2 lesson. All right, so now, all right. Oh, this week, you are still dealing with some more trig. You're still dealing with trig, okay? But if you notice that with the trig functions, okay, you have to use other functions that don't necessarily deal with the right triangle. All right, so for this week, unit 4, let's look at your objectives for this week. Okay, so you're dealing with oblique triangles using the law of sines, using the law of cosines, plotting points in the polar coordinate, solving complex numbers, adding, subtracting, multiplying, vectors, and then you get into the conic sections. The conic sections, you're dealing with the circle, the ellipse, the parabola, and the hyperbola. Okay, and so you are able to graph applied problems involving these conic sections, and then graph the plane curve represented by the parametric equation. All right, so that's what you're dealing with within unit 4, okay, which deals with the trig, the second part of the trig, and then gets into the conic section. So for week 4, you have, again, 2 homework sets, and you have the discussion. The discussion is related to the conic sections, okay? So you are to, depending on your last name, depends on what part of the conic. Let's go to it and see. Make sure that's how I set it up. All right, we have the reading, chapter 6, and then chapter 9. You have lecture on the polar coordinates as well as on the conics. Now, if you find a mistake, you know, please let me know. I will give you extra points if you do find a mistake, and sometimes it happens. All right, so for the discussion, okay, it depends on your last name. Okay, if your last name begins with A through L, you choose one of the conic sections and research how it is applicable to the real world. Be as specific as possible. Put this in your own words. and create at least one original math example. So you can pull it from, the site to find an example, but put it in your own words. If your last name begins with the letter M through Z, then you will research at least 2 useful websites to help you better understand the conics. So look at 2 sites, okay, on the conics, and then summarize what those sites said to you. Okay, put that in your own words. Okay, so that'll be your portion, and make sure that you go back and go and respond to at least 2 other threads. And then if you have a challenge problem, you want to make sure sometime throughout the week that you come back and you respond or give feedback to that problem, or just share your worked out solution to your question. All right, so that's the discussion. If you needed more time for your part B, please make sure that you're working on that and you get that in to me as soon as possible so I can get that graded, and then you can work on the final portion, putting everything together as one big project, that includes your part A, giving a nice introduction of your project, so you notice that a big part of it is writing. So that's why in part B, I'm stressing, okay, tell your story. So I might give you suggested things of, what to incorporate into your project. It's just whatever, I see and what pops in my head as to some ideas that you can include. All right, so in part C, you will actually derive your nonlinear math model for your data and our graph. Okay, it may not be the perfect model. It will be a model. Okay, because if you notice, your graphs won't be perfect graph. It may not be a perfect exponential growth. Okay, but we might have an exponential decay or something. We might have a something that looks more like a parabola. Okay, so you look at it and give your best judgment on the type of nonlinear graph that best fits your data and your graph. And then you'll make conclusions. Was your hypothesis right, or was it incorrect? Were there weaknesses in your project? Could you have done something different? That kind of thing. So what were your weaknesses and strengths in your project? Okay, so you'll put all that in your conclusion, okay, for your part C. So it's putting everything together. Okay, so again, the B is the big chunk, the meat of your project. So once you can get that, then hopefully deriving your equation and then making your predictions based on your model, your 2 predictions, and then talk about your hypothesis, and then making your final conclusions. And don't forget your reference page. All right, so that's that. Now notice there are some resources. One, you have, again, like the sine and cosine rules. Okay, they'll be in the Math Excel as you're doing the homework also. Okay, so if you notice with this triangle here, this triangle is not a right triangle. And again, the thing that they stress is to name the parts of the triangle. So I'm a visual person, so I like to draw my triangle. Okay, if I label this angle A, angle B, angle C, then the side opposite angle A would be side A. The side opposite angle B would be side B, and the side opposite angle C would be side C, okay, as they say here. And so you have the sine rule states that side A over side angle A is equal to B over side sine angle B of angle B equals to the side C over sine of angle C. So these are all equivalent. So if we have and you determine which one, which two you want to equate, okay, depending on what you're given. So you're going to notice that. So this is going to be very useful for you. If you're dealing with the cosine rule, states that a squared is equal to b squared plus c squared minus 2 times c times b times c times cosine of angle A. So this is all multiplication right here. If you notice here, all they did was manipulate this equation to solve for cosine A. So that gives you, some idea of what you'll be dealing with in the week 4 with the trig. Okay, you won't necessarily be dealing with the right triangles anymore. You may have some right triangles, but you'll have some non-right triangles, which you'll have to use different trig equations. Okay, all right. So hopefully that gives you an idea of what to expect for week 4. If you have questions or if you need a particular problem explained, please let me know. I will also just browse through the homework also, just to cover some things so you can see exactly how some of these sine and cosine rules are applied with non-right triangles. So if you have questions, please let me know. Okay.